Hello. So today I start class 10 physics. First chapter of class 10 physics is force. Okay. So this lecture series is for class 10 physics or mainly mentioned in ICSE board. Okay. And the concept all boards are same in chapter in all boards. Okay. So here the first chapter is force. Okay. From class 9 physics we know what is force. Force define a push or pull and SI unit of force is Newton. Okay, we know the class 9 physics, and here we discuss the moment of a force and equilibrium. Topic we discuss moment of a force, moment of a force and equilibrium. Okay, so first group A, and first we discuss what is a translational motion and what is rotational motion. Okay, so motion in two part: translational motion and another is a rotational. What is translational motion? Translational motion describes a straight line motion. Straight line. Okay. So a straight line, like this is a straight line, not like that, a straight line. So I'm very bad in drawing. And here the shape tools here. Straight line. Okay. And here is an object. A circular object is now look like it is a circular object. Okay, is a circular object. Now let's this is a center. This is a center of the circular object. Okay, so linear or translational or the path is straight line means when we applied a force, this is a the diameter of the circle. This line represents diameter of a circle. When we applied a force, uh, force applied in diameter wise. Okay, so if we apply the force here, okay, this point in diameter, then object goes the direction of motion like this. Object goes in that direction. And object goes. Suppose it is a x-axis in x-axis. This direction. So that line is a straight line. This path is a straight line. So these are called translational or a suppose a linear motion. Also a linear motion. Linear means a single line. A line. Okay. So if you force applied and body goes like a straight path. These are called translational motion, and these are direction is very important. Applied force in suppose in the left to right direction, and body rotate or move in the path also the left to right direction. This path. Okay. Next. So what is the rotational motion? Now the topic is rotational motion. So here the rotational motion is very easy. What is rotational motion? A similar first we draw a line. Suppose this is a line, and take an example, a line, and choose a object, circular object here. It's a circular object, and that is the center of the object C. And if we applied a force, okay, the main difference between the translation and rotational motion is that where we can put the forces applied, which position or which point. So in case if a rotational force, we apply the force in that. Okay, so like that control irrigation, it's not a state. So we apply the force in that direction. In that. tangentially. This is a diameter wise. Applied a force in diameter. Applied force in diameter axis. Diameter axis. Okay, and here tangentially. Force applied in tangentially. If we apply the force tangentially, then we see that body rotate. Body, the object or body is rotate. Okay, and you know that rotation is a clockwise rotation. Clockwise rotation. Okay, a very good example of, if I put a same force but magnitude different in that direction, down applied a force, suppose F dash, the same magnitude but in opposite direction, we see the object rotate in that anti-clockwise or counterclockwise. Anti-clockwise. So object is rotated, but also object is move in a straight path. Object moves in a straight path, like object goes like the round and round and round and round and round. And the object is like a this state, or someone pull the object. Okay, like this. An object is moved the same direction, same path, and state and state. But here object moves like a wheel. Will also bike wheel or will also follow the straight path but in circle rotation. This is also a circle, not a circular, but move in a straight path. Okay, and here is the clockwise rotation or anti-clockwise rotation, but depend on where the direction of force. If force is upward direction, in tangentially, force applied in tangentially, so force applied in tangential. Initially, if upward goes in clockwise rotation, is an downward force applied, you get the anti-clockwise reaction. So there is a body is a rotational motion, and here the body is a translational motion. That's a main difference. Okay. Next, in case of rotational motion, we get a moment. In rotational motion, rotational, we get a moment. Get a moment. Okay, and what is a moment? Moment is called a turning effect. Moment is called a meaning of moment is turning effect. So this is a turning effect. Turning effect. Okay. Turning, body get turned or position change when someone place right stand here in some rotation, if body goes down there and the person now look like this. In case of this, someone standing here some distance, the person also standing in here. Okay, there is a rotation means a turning effect, or called of a moment of force, or a moment of force, or moment of force. Moment of force. So what is moment of force? Another name of the moment of force is a torque. So there is a circle. Here is a circle, and that is a center, and we applied a force here, either clockwise or anti-clockwise direction. Sorry, force either top to bottom or bottom to top. Force applied here. Applied force, and that is the radius. Okay, this is a point suppose called P point. There is a radius. Okay, and we see that there's a tangent. The AFA line, this black line represents a tangent, and tangent and radius here we know that always perpendicular at 90 degrees. Okay, so moment of force, or another name is torque. The simple representation is tau. This is called tau. O or U, I think tau. this torque also a vector. Okay, the moment of force that is equal to the radius r cross f, r cross f. If this is a vector, that is a vector. In class 11 you should know that, you know that that is a vector symbol. But here you know that r cross f, moment of force. So we get r f, that is a cross product, and finally that is a trigonometrical ratio. You get a sine theta. What is the theta? Theta is the angle between r and f a, or applied force f a. Okay, that is a f a, r and f a. If and you see that the r and f a angle are also perpendicular to f a. That is always true. 90 degree. Okay, so that is we get a sine 90 becomes 1, so r f or f a, that is the moment of force. So what is the moment of force? Moment of force is a very easy turning effect of a body about an axis due to the moment of force or torque applied on a body. Okay, so if we applied a force in circular object, we in some distance point p from the center, we get a turning effect. And the SI unit of moment of force we get, uh, we know that r is the length, represent only a meter, and f is come a newton, that is a newton meter. Newton meter. Okay, very good. Now, if what is the turning important factor? Okay, so what factor depend on moment of force? If we see that there are some cases, case number one, if r is very less, in case one is if r is very less, that means r is very small, so moment of force also very small, so MOF also very small. If moment of force is very small, so more force we need to rotate the object. So more force we need to rotate the object. Rotate the object. Similar like that the case is if moment of force, suppose the moment of force is called suppose 10 Newton meter, 10 Newton meter, and the force is suppose 2 Newton, and radius is 2 Newton, and radius is suppose 5 meter. If radius decreases, if we get a radius, suppose now radius change to suppose 1 meter, so and result also 10 Newton meter moment of force we need, so we get that the force must be a 10 Newton, so 10 times what we get 10. So if you see that if radius is less, if radius is less, a minimum to need a maximum force to rotate the object, rotate the body. Okay, that's very important. So here we say that the force is also inversely proportional to r if moment of force some constant. Okay, so if more force we apply, then less r is needed. If less r, more force is needed. Okay, and here's a case number 2. Case number 2 is what is case? If someone said that, how first we tell that the angle is always 90 degree. The angle is always 90 degree. If the angle is not 90 degree, okay, if the angle is not 90 degree, if theta is equal to 0 degree. What does it mean theta is equal to 0 degree? Suppose a object here, circular object, and that is the center of and applied force in that direction, F A, and that is the radius also here, that is the R. And can you say that what is the angle between F and R? we see that the angle between F and R also this line, F also the place in this line, that is 0 degree. In case that 0 degree, so moment of force MOF means some value of F is 50 Newton and time 30 meter and sine 0 and sine 0 degree. I know sine 0 is 0. What is the value of that is a 0 Newton meter. So 0 Newton meter means say that the body does not rotate. The moment of force represents the rotation. Represent the rotation. But if a moment of force is 0, means no rotation. No rotation. But body move. Body move means, but no rotation means that body doesn't move. Body doesn't rotate, but body like skid or like in this place body is this from one point to another point, but body doesn't rotate like a body skid. Okay, there's a more friction is here. Okay, now I think that is a clear. Okay, so here is a another two problem. What is the moment of force if the body is rotate? If the body is rotate, we consider here, we know that the body is rotate and theta always 90 degree and a fixed. So we get a two type of moment. There is a two type of turn. There we get two type of turn. Get two types of turning. Okay, so if what is the two types of turning means two types of rotation. Very simple, forward or backward rotation. If object has another object, we put another shape here. Here. Okay, if a rotation look like this means the body move forward. So there is a clockwise direction. These are called clockwise movement. Clockwise movement goes forward. Go forward. And here we get if the body rotate in backward, goes backward. Goes backward means there is an anti-clockwise moment. This is called anti-clockwise moment. Means body goes in that direction. But rotation, but in that direction. So as a clockwise moment, there is an anti-clockwise moment. Okay. Suppose there we get some two or three example here. The basic example, like a wheel. If that is a wheel, wheel and there's a axle okay, and this axle goes in that direction, so we said that force applied, so body goes anti-clockwise rotate. If wheel axle is good in that direction, wheel rotation is that direction, that is a clockwise movement. Okay, the clockwise and anti-clockwise both are true. Like similar like example, door open or door close. So there is a fixed door, that is there is a fixed pivot to the wall, that is a wall. Where is that? Now if that is a center C point, okay, and that is a circle here, and if someone force applied tangentially means in that direction, so door now look like this here, final position here. Okay, so body rotate in that direction. If someone see the top from, if facing top, we see that a body goes right to left, and right to left means here get a anti-clockwise. Anti-clockwise. If someone watching from bottom and we get the some bottom from bottom, say see there, it's a left to right momentum. So left to right is there is clockwise. So another important thing here, the clockwise and anticlockwise both are in opposite direction. If someone said that clockwise is plus, anticlockwise is minus. There's also where depending on where we can see the object. The observer is very important here. The reference point or observer is very important. The clockwise or anti-clockwise movement. Okay, and in the here we see the front of the, this is a board of whiteboard. We see the front. Okay, so I feel this is my right side and this is my left side. Okay, so that's my, I am an observer and this board is an object. I have to measure the which direction will move, so clockwise or anti-clockwise. Here are some example of like nut opener, okay, the range, car range, both also depend on this concept. And another important factor is called couple. Couple. Couple is very important. So what is couple? Is a couple. Couples means two. Means two. So if the object is like a seesaw, yeah, seesaw. Okay, there's a center and someone someone a person sit here and person A, and here the B person uh, uh, sit here, that is B. So if both are in different, if both a mass and force will be different. Okay, this is a weight also, you know, the weight is a force. If someone say weight is WA, here the weight is WB. I know the weight is a force, weight is know that the force. Okay, so also say that someone say the FA and FB, we know that weight is a gravitational force, and that if that is a center and this look like a circular object or circular path, that is a circular path, that is a radius r, that is also radius. Suppose it is a r 1, that distance not a similar r, or so I say that the r, so means if see that if that direction this times this. Okay, so that is a these times these, and these times these both are in equal if they are in balance. If they are in balance, if uh, they balance or equilibrium, we see that the WA times R also equal to WB times R. So balance here. If they are in equal, they are in balance. If not, they are in balance. So what is the couple means? Two momentum force acting simulation. Is that is a circular path, that is a C here, and some force may be applied in that direction FA, and similarly we know that a FM force applied in that direction also called FB. Both are in same. If FA equal to FB, we say that is a FA, that is R, that is a R. So you get there's a two parts, that is here the moment of force in left side, moment of force in the left side is also a RFA, and moment of force also in right side, and for right side, that is also a RFA. So means if in case of couple, the two force must be the same, but finally they are added. If like a paddle, you know, cycle paddle, there is a like a for one pedal here, another is goes down there, forward back. If someone force down here, this down, that is goes up. But and provided this is the same force here, the same force, then here we apply. The couple means the two force, okay, two force, they are in parallel. You see that they are also in parallel. These forces are parallel, very important. These two are parallel, and apply the same object and radius be the same. Okay, so you get a more rotation. See if someone same force, so same force applied here, same force applied here, so double moment of force we needed, so more rotation here. Okay, so that means a couple. the pair of forces from external force and then pair of forces. So means the couple. What is a couple? This is a pair of forces. Okay, couple means a pair of force. It's called couple. But means a two moment of force. Two moment of force added here. Okay, that's a couple. Okay, if they are in balance, the object is and stands still. If they are in not balance, so either this goes up and that goes down, or if that goes up, that goes down, means another condition here, that goes down, so this goes up. Okay, so clear. So like that, the couple here we use a tap. So example is they call it tap. Very beautiful example, a tap. So we see that the tap handle is look like this. Uh, if some this is a rotation, if force is this direction, that force in that direction, the water get out from the tap. Okay, so that is also example of couple. There's a two handle here, two handle here. There's a center, a pivot point, this point here, center point. Like also called it steering. Also example of steering, very good example of steering. Is someone right-handed and left-handed here, an object goes, if right-handed down, left-handed up, so object is in that direction, or vice versa, right-handed this direction, left-handed in that direction. That's also similar here. Okay, this is a couple, means two moment of force will be applied. So I think that is a clear for today's class, or any doubt, so put in comment section. So continue this fourth chapter. Next class we discuss the equilibrium of bodies, some equilibrium and some equation, and there's a two kind of equations: equilibrium, static equilibrium, and kinetic equilibrium, and the principle of moments, and solving some numerical problem. Okay, so we meet in next class. Thank you.